Welcome. In this session, we are going to understand logistic regression model fitting techniques, and we are going to verify whether the generated model is a fitting model or not. Let's get started. It is important for us to verify the model fit. This can be done by computing the pseudo R-squared value. This value is calculated by using the formula 1 minus model deviance divided by model null deviance. This tells us the extent that the model explains the deviance. The following code shows how to compute this value using R. So what we have to do is, we have to use 1 minus, we have to take our attrition logistic model 2 and we have to get the deviance value divided by the null deviance value of the attrition logit model, and whatever value has been computed will be considered as the pseudo R squared value. And finally we are going to print the pseudo R squared value. Let's get started. So what we need to do is, here we are going to perform model fit verification. In order to perform this model fit verification, we have to use 1 minus, we have to get the model attri logi model 2, and we have to get the deviance information divided by attrition logistic model 2, and we have to get the null deviance information, and whatever value is computed we are going to put that into pseudo R squared value. So now we are going to execute this, and as soon as we execute this information we get a value of 0.636581, somewhat like this. So now what we need to do, once this information has been received, we are going to use pseudo R squared value and we are going to compute this information. As soon as we compute this information, we get that the value is 0.636518. So that means the model displays that the model fitting is 63.65%, and that means we have a value greater than 0.5, and this means the model is a fitting model. The model fits perfectly and the model which we have got is a good model. There are various other ways for identification and for checking the model fit. In case if your model gets overfitted, so there are certain information like Kasi separation where the prediction comes nearly perfect. So you have to make sure, in case if you get involved with any of the warning messages, then you have to identify that what exactly that is, and there are some general words of caution which we need to discuss here. So the general words of cautions displays that when we have a problem when the null deviance is less than the residual deviance. So in case if the residual deviance is less than the null deviance, then that means there is a problem. When null deviance is less than the residual deviance. Another way, when we have a very high value of Fisher's scoring iterations, in that case there is a problem, we have not got a good model. And finally, in case if the coefficients are large in size and the significantly standard errors are high, then this means the model generated is not a good model. So what exactly we have here is, you can consider in case if the Fisher scoring has a high value, then this means the model is not a good fit. In case if the null deviance is smaller than the residual deviance, in that case it says that the model generated is not a good model. Moreover, in case if the coefficient values are higher and their standard errors are also higher, then this means the model is not a good model. So this is how you can quickly verify a fitting model as far as logistic regression is concerned. Thank you for watching.